We've seen the term exothermic means a reaction gives off heat, and endothermic means a reaction gains heat. When we're talking about the flow of free energy, however, we use the term exergonic, which means the reaction releases free energy, or endergonic, which means the reaction requires or absorbs free energy. For an exergonic reaction, delta G is negative, and for an endergonic reaction, delta G is positive. The term spontaneous processes are what we use when a reaction has a negative delta G. In science, when we say spontaneous process, all we mean that once it gets started, it does not require any energy from the surroundings. It doesn't necessarily mean that it's going to happen quickly. So delta G, the sign of delta G, can predict spontaneity, but it doesn't imply how quickly the reaction occurs. So let's look at two processes that have a positive delta G and a negative delta G, so we can get a better understanding of this concept of spontaneity. On the slide, there's a picture of two people in a canoe floating downstream. This process has a negative delta G. It is spontaneous. The people in the canoe don't have to do anything for this process to occur. Paddling up the river, however, which is the graphic below that, is a non-spontaneous process. So delta G is going to be positive for this process. Both of the canoe riders are paddling against the current and putting energy into this to make this reaction occur. So spontaneous reactions require no input of energy. They have a negative delta G, and non-spontaneous reactions require input of energy and have a positive delta G. We can also look at these graphs. If we look at an exergonic reaction where we have a sign of negative delta G, the reactants have higher levels or more free energy than the products. As the reaction goes forward and the reactants form products, free energy is lost. An endergonic reaction, on the other hand, a non-spontaneous reaction, needs energy to happen, and so the products have more free energy than the reactants. So the sign of delta G is positive. One of the reasons we care about delta G is that in biological systems, the free energy that is released in one reaction is often used by another chemical reaction. And this happens in adenosine triphosphate, otherwise known as ATP. ATP is sort of the currency of energy in living systems, and it utilizes the change in free energy from other reactions. And one more time, the spontaneity of a reaction, the sign of delta G, in other words, does not tell us how quickly a reaction will occur. For example, the change of a diamond to graphite is actually spontaneous. It has a negative delta G. However, this process takes millions and millions of years, so you don't need to worry about your diamond ring turning to graphite.